So if there was one big challenge that you could solve for the future of defence vehicle propulsion systems, what would that be?
I think in the short term, finding more space on these vehicles would be really nice.
Hello and welcome to Ingenuity, the podcast series from HORIBA MIRA, where we go behind the scenes of next generation vehicle development. In each episode, I interview an expert in their field and find out the mastery behind the magic. I'm thrilled to be here today with Alisdair Bowie. Hi, Alisdair.
Hi, Sarah. Good to be here.
Thank you very much. Now, my first question, I know we connected recently through the STEAM Ambassadors, which is a volunteer program from HORIBA MIRA where people from across the business go and engage with local schools and colleges. I know that's something that you're very passionate about. We'll talk about that a little bit more in a minute. But what I wanted to do first of all was just understand a bit more about you, your career journey, what motivated you to get where you are today. Okay,
well, I'm one of the lucky ones where I was quite young when I knew what I wanted to do. So way back in the good old days of 1997, I decided I wanted to be in Formula One. I wanted to be a racing driver. We took one look at how much it's going to cost and decided can't do that. What else can we do? I want to build the cars. And how do I build the cars? Become an engineer. So from that point onwards, it was just how to become an engineer, doing maths, physics, that type of thing. Went to university, did mechanical engineering. Was on the right path. Then joined ProDrive, automotive technology, and started working on things like hybrid vehicles and was like, oh, this is fun too. So then after a couple of little blips due to the financial crisis, ended up at MIRA, and from then on I've been just working on electrification projects and weird and wacky wild things, and it's just great fun.
And what's motivated you? Has it been that kind of drive to net zero, to the transition to zero emission vehicles? Has that been something that's been motivating for you?
Lately it has. I mean, I remember during a lockdown, you walk around town and the air was cleaner, and then you're like, okay, it does make a difference. But from early in the career, it was just more, it was an engineering challenge. There were really difficult problems to solve, like fitting things into vehicles, how we're going to do it, how does the strategies work, when do we turn the engine on and off, all that type of thing. It's like brand new. We're discovering things, for the first time, or the first time in a long, long time anyway, in terms of electric vehicles. And it was just interesting, it was challenging, and those challenging things are good fun.
And I know one of the areas you particularly work in is defence. And obviously we've seen a significant transition in terms of, as you say, electric vehicles in the passenger cars. How is that working out in defence? What are the challenges that you're finding there?
The challenge at the moment is nobody really knows what they want to do with it. They know that electrification exists. They know that net zero is a wider government policy. But from an MOD point of view and a defence world point of view, they look at it as operational advantages. So can we use electrification either to improve the performance of vehicles, reduce fuel use, which is important for things like fuel reserves, because that's one of the logistical challenges that defence have. One general told me that the two biggest logistic headaches are water and fuel. So if we can reduce that logistical burden of fuel, makes their life easier, and it just makes that side of it easy. There's less reliance on countries and less reliant. You can be energy independent as well. So that is one challenge. It's just trying to understand, what do you want it for? What do you want to do with it? Because we know how it works on the passenger car side. They just know about it from passenger cars, and how can we integrate it into these vehicles?
And I guess they've got real challenges that'll be different from passenger cars in terms of the infrastructure, in terms of the energy storage, those types of things.
Yeah, as we've seen in passenger cars, batteries for these types of vehicles are big. They get in the way. They get in the way of boot space and things like that, and it takes a lot of engineering to package them in a way that those things are impacted. And the vehicles we've seen, particularly in the UK side, they're already tightly packaged. They are full to the brim of equipment. So if I come along and say I want to fit a 800 volt, hundreds of cells into this vehicle, they're just going to laugh at me. So one of the lessons we've learned in the passenger car side is when you adapt an existing vehicle, you're always compromised. We used to put batteries in the boot because we didn't re-engineer the body shell, didn't have the time or the money in these types of projects. And what we found was you compromise the handling of the vehicle. So whilst the fuel economy is great, suddenly the car's like a pendulum because the battery's at the back and it's spinning off everywhere. So engineering these vehicles from scratch, you need to take into account electrification. But we're in a bit of a budget restricted time, I think it's fair to say. So re-engineering these vehicles from scratch probably isn't feasible. So what can we do? And it's a quite an interesting problem to solve. Where are we going to find these wee nooks and crannies around the vehicle, and what can we do to get things in there that can introduce electrification? And it might either be for powertrain, or it might be such that you can turn the engine off and maintain power to different systems. So again, there's so many options. It's like starting with passenger cars that we did 10, 15 years ago. Like it's the big bang we're at, and it's just going to expand. And it's how we do that is the really interesting part.
And this sounds like, you were talking about becoming an engineer, what motivated you was solving these challenges. Actually, yes, in an ideal world, you'd start from scratch and you'd engineer the perfect vehicle for the optimum environment. But actually what you're talking about now is having to work with that challenge, having to kind of modify, adapt, be agile.
Yeah, I mean, if we started from a clean sheet of paper, it'd be too easy anyway. Yes. So let's just do the hard way.
Exactly. We're always going to make it slightly more difficult for ourselves, aren't we? And are there other things in terms of, I guess, particularly electrification and passenger cars that we've learned? I don't know, things like maintenance and the kind of transition there. Is that important to defence?
Yes. If you put more bits in a vehicle, there's more things to look after. So things like, I would now have to put another cooling circuit in. So I've already talked about there's space constraints, and I know colleague James spoke to that in a previous episode. There's space constraints, and I've got to fit all that in. If they become compromised, we could affect the kind of maintenance of these components. Are they going to fail sooner? And because there's no space, they're in horrible, hard to reach areas. So I don't want to go and replace them. So some of the things we've worked on, and this kind of came from how do we improve energy efficiency in electric vehicles, is we can put sensors in these systems as they're installed and monitor them and gather that data and analyse that data. And what we can do is look at, is this behaving differently, like kind of predictive maintenance? Can we detect faults before they happen so that we can schedule these fixes during major services? And that's that kind of new technology that's coming from data analysis, machine learning, AI type of things. We can use all that to do that, and it's a really interesting field. And again, we've seen all this data in vehicles. It's just now like, what can we do with it? This is new. This is interesting. So, and
I imagine operationally in a military environment, that as you say, that maintenance it's important in a passenger car, but it's surely critical in a military vehicle.
Yeah, I mean, it's not as if you can ask the enemy to stop because you've got to go change something in your car.
Exactly.
So you've got to carry on. And what you can do, and what we've seen in some projects is, yes, we know there's a problem here, but we're going to run it because we're running away or we're engaging. We have to do something. So you run it until it blows up. And if it does blow up, we make sure that it fails in a nice, safe way so no one's hurt, and we can carry on and continue.
And what about climatic conditions? Because again, important in a passenger car, but I imagine military even more important.
Yeah, and especially, they find it very difficult already just keeping the occupants cool or the occupants warm, depending what environment they're in. When you start to introduce things like batteries into the equation, so batteries like to be in similar conditions to humans. They don't want to be too hot, they don't want to be too cold, and if they do, nasty things happen. We as humans get grumpy, batteries start to get a bit explodey. So
that's probably worse.
Depends on the person.
Yeah, that's true.
So that becomes really critical because engines will run at some 60, 70, 80, 90 degrees Celsius, but batteries need to be like humans, about 30, 35, maybe a bit warm for a human, but you're in roughly the same region. And that, if you're in extremely hot climates, how can I cool? There's no, the air outside is hotter than it wants it to be. So now I have to introduce either more systems or upgrade existing systems. And that is, again, another logistical challenge to this type of engineering.
And it's the drain on power again, I guess, isn't it? That's
and then the fuel consumption's going up.
Yeah.
So I'm going to put all this stuff in the vehicle, make the vehicle heavier to try and reduce fuel. And I'm going to use the same amount of fuel because I've got to cool everything. So there's that as well. So that basically cost the MOD money and weight rather than done anything good. Yeah. So it's a really a typical engineering exercise. It's compromises have to be made, and it's just a very, very difficult one.
And it's interesting what you were saying at the beginning about actually the emphasis from an MOD perspective is less maybe about zero emission, and actually more about how do we reduce fuel, how do we reduce water. Yeah,
and improve performance. Like we've seen some systems where the vehicles can almost spin on the spot, and that's really good if you have to turn around and run away. So, or if you need to turn around and engage, that manoeuvrability is really important. But also if you've got a vehicle that has to have good performance, it needs to get somewhere quickly, if you can boost that acceleration, sort of like a motorsport style system, recover energy and brakes and use it during acceleration, again, it reduces fuel or improves performance. So there's loads of different avenues. It's nice to have that extra attribute to be chasing. Like because as engineers, and automotive engineers, how do we make things go faster is always pretty cool. It's interesting to get fuel consumption down, but it's fun to get performance up.
Yes.
Especially out in the track.
Yes, exactly. And I guess that's your Formula One passion kind of coming out as well.
Yeah, that's the racing blood, isn't it?
Yes, yeah, exactly. So let's talk a little bit about the STEAM Ambassadors program and your passion with skills. And I know you almost single-handedly kind of ran that program for a number of years. Why is that so important to you? Why is kind of supporting the next generation so important?
I think it comes back to when I first started at MIRA. So I started in 2011, and we had a staff meeting talking about the results of the previous year. And I looked around, and there was a bit of a generation gap, and I was like, oh, there's not a lot of young engineers around. I mean, in my university course, there was about 110 people. I think maybe one or two of us went into automotive. So that's a really low percentage. And if that's across the board, that's not great. And then when you look into the figures, like we had a shortage of engineers when I started. The shortage has got worse, and the shortage is going to get worse. So it's like, right, okay, well, I can sit and moan about lack of staff in the future, or I can go out and tell people what engineers are. So, I helped run an after-school club running a 24-volt electric racing car. I then moved over to going to different schools of different ages, just talking about what an engineer is, because if you type it into Google and look at Google Images, there's loads of people in hard hats pointing at blueprints, whilst engineers, as we know, do loads of different things: civil, mechanical, electrical, software, processing. Some people will think engineers are the people that come out and fix the boiler, which they are, but there's a more wider range than that, and it's about telling people these people are engineers and scientists and technologists and mathematicians. This is a type of career, this is what we do, it's problem solving ultimately at the end of the day, and it's really interesting, and please consider it. And I hope some have. It's very difficult to quantify, but if you can get that one person convinced, that's one extra engineer over the rest, and that's a positive.
Yeah, definitely. And I think you certainly notice a difference actually in MIRA now at the tech park. I think you do see a lot of younger engineers coming through.
It's changed. I mean, the park has changed tenfold, and the kind of demographic of people has changed tenfold, and it is good. We have a good influx of graduates and apprentices every year, and they go on, and they some leave, but a lot of people stay, and a lot of people, the old adage of MIRA was you're here for 6 months or you're here for life. So sort of like prison, but in a good way. And yeah,
people go and then come back. I've seen a lot of that.
Yes.
Realise the grass isn't greener.
Yes, that happens definitely. But yeah, it's just good to go out and promote it. The unfortunate thing when you do go out is there are an awful lot of boys in the class that want to talk about engineering, and I've already talked about a shortage. And now I'm cutting the demographic in half. So instead of that wide array, I've already got half gone. And now I've got to convince a smaller set to do something that want to do other things. So that number's reducing to a very small number, and it's like, it's I don't know how to solve it. I mean, some of the events I've done are kind of like Women in Engineering Day and things like that, and you have to address the elephant in the room. I'm a man. I'm here because there's not enough of girls in engineering. Please do it. It's fun. It's great. You can do it. There's nothing to say you can't. The only thing the line I use, the only thing that I've done that, let's say, women can't do is use the gents' toilets. And if they're really desperate, I'm sure they could. So, there's nothing gender-based in engineering. It's just problem solving. Yeah. That's an anyone activity. So,
and I think it's perhaps more creative as well than people realise, in terms of, as you said, you've got that challenge, you've got different parameters that you've got to work with, you've got an end goal, there's a lot of creative thinking in there, isn't there?
Yeah, especially when the problems get very tough. That's where the more creative people come up with more out of the box solutions. I mean, traditional creativity of design, designers will clash with our thermal team because they want the car to look in a certain way, but the thermal team want the radiator to be open to get cooling. So there's that as well. So how do you solve that? And that is, again, creativity to how am I going to get these two people to get on with each other and make the right decision. So we have lots of different people come from lots of different backgrounds, and some people have come from the art world. Some are like myself, like traditional engineering, going to university. Some people have done apprenticeships, and some people have just gone to work after school. They've just, okay, I want a job, let's go. And they've all kind of centralised at the same point at MIRA. So, engineering is a diverse business, and having lots of different people with lots of different skills and background, it helps it, because you get different viewpoints. If you get everybody who did mechanical engineering, you're going to get a mechanical engineering solution. If you have a bunch of different people who did different backgrounds, engineering, science, even art, some people that the art and design was their background, we're going to get a better solution because there's more inputs to it.
So tell us about your career highlight today and how you get the next generation excited about engineering.
My career highlight today happened it was one of the first things I did at MIRA. It was one of the reasons I was hired, which was we were building a hybrid electric bin lorry, a refuse collection vehicle, if you want the correct term. And I was asked by my managers, can you do the control software for the entire vehicle? And I was like, yeah, sure, I'll give it a go.
And you were a young graduate engineer.
They knew I hadn't a clue what I was going to do, but they were willing to teach me. And we got it working, and it all worked. There was the drive system, hydraulic system, air system for the brakes, getting the screen to work. If I turned the steering wheel, did the rear wheels move? Independent rear wheels, all this stuff. So I was in the deep end, but it ran reasonably well. And that was like, it was tiring, but it was quite a proud moment, because it was like, I did it all on my own. Like there's OEMs around that have software teams of about 300, 400, 500 people. And there was just young little me, just with my laptop, firing software into it, seeing if it'll work. So that was really good. But funnily enough, that never really plays well with the kids. When they see it, and when they see it in operation, see videos of it, it's like, oh, that's cool, because it can crab, it can do really cool steering things. But things like our rapid intervention vehicle that was behind you and James in one of the previous episodes, I worked on that. 300 horsepower monster, trying to get it to grip, not spin its wheels and all stuff. That was cool. Talking about the track as well, like doing driver training on the number ones, the banked circuit, lift off oversteer, drifting, all that type of thing. That really gets excitement. I usually don't mention charging electric vehicles, because watching an electric vehicle charge is not the most exciting thing in the world. Meetings, no, I try to avoid that. Although I do be honest with them. I will say, I'll do this really cool stuff. I'll be out on track, driving this vehicle, getting the battery to this charge. I'm on the number one of the high-speed circuit, flat out the whole way around. But then I've got to watch it charge and make sure it's charging and not catching fire, and making sure it works. So, it's like, it's the laws of thermodynamics and Newton's law. Yeah. It's like, you can't have one without the other.
Yes.
But I try to avoid meetings and all that sort of stuff.
But what's interesting about that is that it's that sense of achievement, isn't it? In terms of, as you say, you won't necessarily like every job that you have to do in order to get the end result, but that sense of achievement when you have done it, and that autonomy. I think when you said as a young engineer you were given that project to do, I think that's very typical of HORIBA MIRA, isn't it? That we've got real autonomy here in terms of our projects and just giving things a try. Really, I mean, I guess that's working in R&D, isn't it?
Yeah, and now I'm a bit older, a bit greyer. I've got young graduates coming through, and once they've got a stable footing, that bit of confidence, you can just go create this software for this hydrogen truck, which we did with one of our graduates just come out the program. Just, there you go, mate, carry on. Just like I was, and it's good because you've got to figure out things for yourself. So you get that problem-solving kind of algorithm in your brain going. You get that self-autonomy. We're always here to support. But it's always to nudge you in the right direction rather than go do that to that, and that's enjoyable as well. But as I'm getting older, I'm seeing other people doing the work, and I'm just standing, taking the credit for it, saying I told them to do that. So which isn't as fun, but it's great to see. I mean, especially when it's something. I looked at one part of our calibration optimization side. I don't know how to do that. There you go, mate. Give it a go. And they sorted it. I'm like, yeah, I totally understand that. That's fantastic. Well done. So
that's your job from now on.
Yeah. Fine. If you hire these really good people, like you can do excellent things, and I could be like, okay, this is good.
Yes.
So
exactly.
Yeah, it's interesting.
And coming back to some of our chat earlier about battery technology and military. What are the other applications for it beyond vehicles, or is that the real focus?
There is a focus in vehicles, but it's the learning we get from it. So the batteries that are in electric or hybrid and electric vehicles, they have to have high power and high energy, and you can't really get both. Just, again, it's one of those restrictions of physics that stops it. But the lessons we've learned on it, so if you run a high power battery, you need to cool it. But these high power batteries can be really useful for things like counter drone measures, because they're very high power, but they have to be very small. And that's the type of challenge that we've had in the passenger car world. And so those lessons that we've learned are really applicable to that. Other things like we need very large energy in very small spaces. Again, people want range in electric cars, so we have to get energy in, but they also want the performance, so we need the power as well. So all these compromises we've made, all these lessons we've learned are really applicable to those parts of the defence world.
And you mentioned hydrogen earlier in terms of HGVs. Is that something that's playing a role in military vehicles as well?
It is being investigated. I think not as much as electrification. I think a lot of the defence world has to really mimic what's going on in the civilian side. If I'm in a certain part of the world, I don't want to be there plugging a vehicle in and going, oh, I don't have the right charger, or they're using a different type of fuel, whether it's e-fuels or hydrogen and all that sort of stuff. So the world almost needs, the civilian world needs to like converge on a solution, and then the defence world can take advantage of it. That's one of the the prime example I think of is in 1940 when Battle of France, the German motorised divisions were coming through France, and they were using French petrol stations to refill their vehicles, so they don't have to wait for supply lines. So if they weren't able to do that because they used a different fuel or different nozzles or any of that, that would have happened. Maybe that's a good thing. But that's one of the lessons from history, that whilst we could develop these really brilliant defence-specific fuels or charging or receptacles to refuel things, there's no point if you're in the field of battle and you don't have the right equipment to do it. So it's got to be adaptable, it's got to be usable. I think we need to take lessons from the civilian side.
That's really interesting. So that comes back to that practical kind of real world application, doesn't it? That yes, again, in an ideal scenario, you would have a defence specific tailored to all their particular needs, but actually that doesn't play out when you're in the real world.
Yeah, it's all these get creative solutions that we talked about earlier, but you also need that pragmatism. That is it really going to fly? Is it really going to work? So that, again, that's another challenge, another compromise we have to make, because those two things are diametrically opposed. There's creativity, but is it the most pragmatic solution, or is it cheap, or is it accessible? Again, there's
to find a way to meet in the middle.
Yes.
Yeah. And that, I guess that comes from bringing, as you said, people from lots of different disciplines and backgrounds together, that you find that kind of middle ground and middle solution, optimal solution, I should say.
Fine, if we lock them in a room and tell them to fight it out, whoever comes out gets the
We'll
decision.
get there eventually. Yeah, exactly. I wanted to ask, actually, so my background is technology. And cloud technology, and then more recently into data and AI. Is that playing a role? I mean, you mentioned data analytics earlier. Is artificial intelligence playing a role in military vehicles?
I'm not sure about vehicles yet. I think it is definitely playing a role in the defence industry as a whole. And I think we need it, though, in vehicles if we're going to analyse data, because we can get millions of data points coming off, and I can't ask a poor engineer to sit and analyse that data as it comes through live. So that's where we can highlight predictive maintenance is a great idea for machine learning. If we have 100 vehicles and we see that the gearbox is vibrating a certain way, and there's one vehicle that vibrates in a different way, there's a problem. What type of problem is that? And if we see multiple failures in testing, we can characterise those, like the vibration. So my background at university was looking at diagnosis of gearboxes by looking at the vibrations that come off. So if you have a chipped gear or a missing tooth, it gives off a different vibration. So again, it's about characterising it, and it's far easier to do it with machine learning than me in the university labs till about 11 o'clock at night trying to get things to match. If I can get a piece, I can do it.
How are you measuring it?
It was through little vibration sensors we just put on the gear casing, and as it came through, we picked up the signal, did lots of fancy maths that I still don't quite understand on it, and it comes up with spikes. And if you look at if the spikes change, there's something going on, which would have been really good. That was what the theory said, but the bench that it was sitting on wasn't connected to the ground, so it was vibrating as well. So there you go. At least I knew there was a problem.
Not the optimal experiment.
Yeah, but yes. We thought that wasn't at Mira, I should say.
Yeah. So if there was one big challenge that you could solve for the future of defence vehicle propulsion systems, what would that be?
I think in the short term, finding more space on these vehicles would be really nice. But I think in the medium to long term, just getting integrated with the manufacturers at an early stage, so we can claim that space and say, if you want these systems, we can do it, but we need to put them somewhere. So let's work together in doing that. And it's something that we at HORIBA MIRA have done for years. Like our integration of hybrid systems into passenger cars initially was, what space have we got, stick them in, all the way through to, if we re-engineer the vehicle platform, we can fit it in. And I think the same principles would apply in the defence world as well.
So it comes back to bringing even more greater minds together in that room to solve that challenge.
Yeah,
absolutely. And my other question I love to ask is about the crystal ball. So experts in their field, what do you see in the crystal ball for your future in terms of defence vehicles?
Hopefully, new fleets coming soon. And that means that is the clean sheet of paper I was talking about before, but building on the lessons of previous vehicles. So it might be, when you look at previous vehicles like the Snatch Land Rover, you compare to what they use just now, which is like things like the Foxhound vehicle, they're totally different because the requirements have changed, and a lot of the kind of lessons from the last few years have been played out. And we need to take these lessons and put them into new vehicles. So I think the long term, probably better integration of electrification into these vehicles, such that the fuel that we have, we can use wisely. We might be looking. I think in 10, 20 years' time, there'll still be fuel in these types of vehicles. Now, whether that is diesel or an e-fuel or possibly even hydrogen that they're burning, I think there'll still be an internal combustion engine, because I think a lot of people know it, understand it. But there's so much cool things we could do to make it, more performance, better economy, better strategic and operational advantages to these types of vehicles that we could engineer in. And I think that's what I see in the kind of medium to long term. Hopefully I'm right.
Yes.
My lottery picks would suggest I'm not, though.
We will watch this space. But yeah, as you say, I think that kind of integration and that planning for the future, where this is going, how do we work together to secure that and to plan it more efficiently, more effectively, bringing some of that creative thinking. I think that sounds brilliant.
Yep.
Thank you very much for joining me today, Alisdair. I'd love chatting with you. I'm always really inspired by how much you give back to the next generation in particular, because I think that's so important. So thank you very much for joining me today.
No, thank you. Pleasure.